Hi and welcome. Today I'm going to examine if ChatGPT 4, which is one of the best large language models that are available today, can be used for polymer mechanics understanding and teaching. And the idea here is that ChatGPT 4 has been shown to do really well on certain tests, like medical examination tests, lawyer tests, and things like that. And the question is, can we use this tool to learn and teach ourselves about polymer mechanics? Do we need to buy books like the book I wrote, or can we just rely on these language models to teach us the topics that we care about when we study polymer mechanics? So to do that, I will start with the study that I performed last year. Back then, I examined the currently available GPT version that was available at that point. And I did this study about a year ago, and I examined it by asking 7 specific questions. And what I want to do today is compare the answers I got last year to the currently best language models and the answers that we get today. And the specific language models that I want to examine is ChatGPT from last year, December 2022 version, and the currently available version from GPT-4. So this is considered the best large language model that is available today, and that's the one sort of that everyone else tries to beat. And in addition to that, I'm also going to examine another one that's called Mixtral 8x7b. What's cool about this model is that it's publicly available. You can download this model directly from the Mistral AI website, and it's available for you to run on your own computer. You don't need an internet access. And this one has got pretty good reviews online, and I was excited to examine this one too, because it's really cool to be able to run this on your own computer. And the questions I want to ask are the same as I asked last year. So some of these questions are more exciting than others perhaps, but these are what I used last year. That makes it really interesting to compare. How much have these tools improved over the last year? And you can see some of the questions here. These are the questions that I examined last year, and I asked them again this time to these different language models. And the answers that I get back are sometimes good and sometimes not so good, as one would expect. So I'm going to highlight today one question that the language models get particularly wrong, and one that it gets relatively well. So I'm going to start with the one that the language models answer pretty well, and that's the last one here. How does polyethylene fail? So it's a little bit broad question, and perhaps it was formulated in a little bit weak way, but that's the idea there is to examine how much the language models can understand and give an answer to this. So here are the answers. Here's the specific answer that I got last year when I asked this, when polyethylene fails. It talks about different causes of failure: mechanical stress, thermal stress, chemical attack, and fatigue failure. Overall, a pretty good answer to, I thought, at that point. It sort of lists the different classes of failure that can occur. It doesn't obviously give you any more details about it, so that's why I don't give it more than 3 out of 5 stars for that answer. The Mixtral large language model that's available now, you can run it by yourself, and it has free weights that you can download from the web. Is a little bit better, I think. It has a little bit more insight about what's going on here. It talks about the different classes of failure: again, tensile compressive failure, creep failure, fatigue failure, environmental degradation. So I think this is a pretty good answer. It's sort of as good as one would expect to such a broad, open question. So I like this answer. Actually, it's a pretty good one. GPT-4 has a longer answer, and if you have used GPT-4 recently, you may know that it actually also gives you references, or it gives you indications where it gets its answers from. So this is the answer I got from GPT-4. It's mechanical, thermal, environmental, and then it's a long list of reference here. But it's less strong, I think, than the Mixtral answer in this case. So I'm giving it 3 stars out of 5 in this case. But it's overall a pretty good indication of what to research next if this is something you're interested in. What I want to ask now is another question that all of these large language models get typically really poorly. And here's my question for that is, why are some common limitations of linear viscoelasticity? So ChatGPT, I got 1 star last year when I reviewed this. It's just wrong in many ways. And it says that both elastic and viscous behavior, that's good. only be valid for materials that exhibit a linear relationship between stress and strain. That's just absolutely wrong. That's not how linear viscoelasticity works. It doesn't have to be a linear relationship between stress and strain. In fact, it's not. The word linear in linear viscoelasticity refers to the linear viscosity, not that the stress-strain response is linear. So this is very misleading and not a particularly good answer. The mixed trial database, or the large language model, is also a little bit weak, and perhaps it's a little bit better, so I get a 1.5 star for answer here. But it's still totally misunderstands it. Small and low loads, yeah, that's maybe okay. A reversible manner, like this is just not right. It gets the confusion about that the stress and strain have to be linear in this case as well. So it's not a good answer. If you think of this as a good, if you try to learn linear viscoelasticity and this is your answer, you're clearly going to be disappointed, because that's just not wrong. GPT-4, I gave 1 star again. It's a long list of references, but it's really not a good answer either. It requires a large number of material parameters, some of which you measure and calibrate. That's wrong. You can do a single relaxation experiment to get the whole set of viscoelastic parameters. And a linear relation between stress and strain again. Like it's just wrong. This is just not what you want to do. So if we summarize all of these questions that I have, what I like about it is that it gives you an indication of some answers, but for the field of polymer mechanics, all of these large language models are pretty weak. The best one overall, when I compare all answers, is GPT-4, as one would expect. Its answers is slightly better on almost all questions that I asked. Mixtral 8, the new one that you can run on your own computer, is surprisingly good. It's substantially better than the version that was available last year. So what did we learn? These tools, these large language models, have improved substantially during the year, but they're still very weak when it comes to polymer mechanics. I would not rely on this to educate yourself on these fields. I think you really need to do web searches, you need to read books, you need to study yourself to understand it, because many of these tools just give the wrong answers still. We'll see what happens next year, but this is the state of the art today in 2023.